Good morning, mathematicians. Today we're going to be exploring sine and cosine a little bit further with our unit circle. So I actually want to take a flashback and complete our do now. So based on our unit circle, we know that it has a radius of 1 and a center at the origin. I'm asking you which equation here best represents, or which equation here would represent the equation of our unit circle. So I'm looking at these choices here, and I already know that there's two choices that I can easily eliminate just by looking at these options here. So I'm looking at choice A specifically, and I'm going to go ahead and say that I can easily eliminate that. And the reason how I know that is because if x plus y equals 1, which is choice A, and I'm asking you to, let's just say, like, rearrange this in y equals format like we're used to, right? So we would go ahead and subtract x from both sides, and I would have y equals 1 minus x. And then at this point, I know that I can eliminate this choice here because, plain and simple, we have a linear function. That's representing a linear function there. That's in the format of y equals mx plus b. The only thing is we have it rearranged. Like, I look at this, I know my slope is -1. I know my y-intercept is +1. So this choice right there, eliminated. If I look at B here, you should be able to look at choice B here and know, oh, that is a quadratic function. I could call any one of my students in here from Algebra 1 because I embedded this in their head, and they would be like, your highest power that I see is raised to the second. And since it's raised to the second, that means you have a quadratic function. Definitely not a circle. So that leaves you with your choices of C and D. So let's pretend that, like, I don't remember what the difference is between the ones here and then this just being numbers. And let's use a helpful hint that I put for you guys of saying we can take any point, oh my goodness, any point from our unit circle that is already on there and plug it into our equations and see which one of them is actually going to be equal to 1. And that can prove what your actual proper equation will be. So any point on the unit circle, whether you're picking like 1/2 comma square root of 3 over 2, or you can do negative square root of 2 divided by 2 comma negative square root of 2 divided by 2, any point you want to. I'm going to go ahead and pick a simple point like 180 degrees. I know that on my unit circle, 180 degrees is going to give me the ordered pair -1, 0. Okay? So since that's the case, let's just look at choice C there. I have x squared plus y squared equals 1. Well, if I look at that ordered pair that I just have developed, I know that my x value is -1 and my y value is 0. So I'm just going to go ahead and plug that into that option there and see, like, does that actually give me 1? So I'm going to have -1 squared plus 0 squared equals 1. And now I'm just going to straightforward and evaluate. -1 squared, that's going to give me 1. 0 squared, that's going to give me 0. Oh, 1 plus 0, that's definitely going to give me 1 equals 1. That would work for any point that you substitute in here. So that is proving that that is in fact your equation for the unit circle. If you're having doubts, I can go ahead and test choice D, which is saying x minus 1 squared plus y minus 1 squared equals 1. I can look at this and just be like, I know that this isn't right because this is telling me that I have a center of my circle at 1, 1. But let's go ahead and prove it. We said my x value was -1. I'm going to plug that in for x. My y value was 0, so I'm going to have -1 minus 1 squared plus 0 minus 1 squared equals 1. Now, be careful your order of operations. I'm doing my parentheses here first. -1 minus 1 is going to give you a -2 squared. 0 minus 1 is going to give you a -1 squared. And at this point, you might go ahead and be like, oh, this definitely can't be my option. Or you can keep going and know that 4 plus 1 is not going to be equal to 1. So that is certainly not your equation. So now you guys know the equation for your unit circle is x squared plus y squared equals 1. The 1 is representing your radius of the circle, and I don't have any numbers being added or subtracted to my y and x value because my center of the circle is at the origin. Okay, feel free if you're having doubts, pick any other point from your unit circle and test that for me, and you'll still get the same answer here. So you guys will need a calculator for today's lesson. We're going to start looking at values that are not on your unit circle. And I want you guys to notice, very plain and simple, I give you guys a Pythagorean identity. Cosine a squared plus sine a squared equals 1. Well, if we look at our equation from our unit circle, and if we think back to what we learned on Tuesday, what does cosine of x or cosine theta, whatever you want to call it, cosine whatever, a, alpha, beta, anything, is equal to? And what did we say that sine, theta, beta, alpha, any of those letters are equal to? So you should be thinking cosine of theta, we said that those are your x values on your unit circle. And when I'm saying sine theta, I'm talking about my y values on my unit circle. So since that's the case, I can go ahead and look at my equation here, my x squared plus y squared, and I can actually substitute in like, oh, what does x actually mean here? So I know that x is really cosine of theta. What is my y? Oh, y, we said that that was sine of theta squared equals 1. So this right here, that's the same exact thing as your equation for the unit circle. They mean the same thing, because cosine, that's just a fancy way for x. Sine, that's just a fancy way of y, and it's always equal to 1. So you guys just discovered your first Pythagorean identity. So I want to start looking at points that are not on the unit circle. So I'm saying to you, angle A has a terminal ray that falls in quadrant 4. So that's the first thing I know somewhere in the 4th quadrant over here, I have angle A. That's going to represent angle A. And they tell me that sine A is equal to 12 over 37. So since that's what sine A is equal to, I can go ahead in my equation here and take out sine and plug in 12 over 37. Because that's what they said that that was equal to. And I'm asking you to find cosine of A. So all I did here was substitute out what sine A was equal to because that's all they told me. And now I want to solve for cosine. So your first step here, how do I go about solving this? Thinking always of isolating, think of this as a variable, just like if I said to isolate x. So you're going to have to go ahead and do your exponents. 12 over 37 raised to the 2nd power. So I'm going into my graphing calculator. 12 divided by 37. I'm making sure I put parentheses around that. And I'm raising that to the 2nd power, which gives me that long, scary decimal. But I know if I hit math, enter, enter, that gives me 144 divided by 1,369. So I have 144 divided by 1,369. Some of you might be thinking right now, like, holy cow, I don't have a graphing calculator. Well, that's why your very first assignment in this class was to download a graphing calculator. If you're not feeling confident in your answer, you can also break up your values here. I can go ahead and do 12 squared. Okay, 12 squared. That gives me 144. Then I can go ahead and do 37 squared. That gives me 1,369. You should have a fraction in between it. That's all your answer there came from. Now your next step, again, I'm trying to solve for cosine of theta. So next I should be subtracting 144 over 1,369 from both sides of your equation. Just like always, if you do something to one side and you don't do it to the other, you no longer have a balanced equation. So I'm just, again, going right to my calculator. 1 minus 144, make sure, again, you have parentheses, divided by, anytime you have a ratio, you should have parentheses. Again, scary number. Math, enter, enter. Oh, that looks a lot better. So I'm going to have, let me go over here for space purposes, cosine theta squared equals 1,225 divided by 1,369. Your last step, well, that's not cosine, that's cosine squared. So you have to go ahead and get rid of that square root. You have to get rid of the square, that power of 2, which means you should be taking the square root. You're going to take the square root. What this essentially means is you're taking the square root of the number in your numerator, and you're taking the square root of the number in your denominator. Or you can go ahead and do it all at once, whatever is easiest for you. I know that the square root of 1,225 is going to give me 35. And I know that the square root of 1,369 is going to give me 37. So cosine of A, or theta, whatever you want to call it, is equal to 35 over 37. So notice that's that's definitely not a point on your unit circle. You cannot use your unit circle to help you here. You had to go ahead and use your equation and algebraically solve it. Okay? But last key thing here, they told me that it lies in the fourth quadrant. Since it lies in the fourth quadrant, I need to be thinking in my head like, okay, all ordered pairs in the fourth quadrant. I know that my x value is positive and my y value is negative. So if I'm looking at my answer here, cosine of A, well, that's representing my x value, so this should be positive. If I was solving for sine, then I would have to put a negative in front of it to actually show the accuracy of the quadrant that it lies in. So if it's something in the third quadrant, remember, both your values should be negative. If it's something in the second quadrant, you should have a negative x value and a positive y. Remember that acronym, all students take calculus. That will help you. First quadrant, everything's positive. All right. The rest of your PDF file is all practice examples on this concept. There is 2 very similar to the one above, and then 2 multiple choice. Have fun!